Welcome to part two of revising chapter 8, statistics on the IB/AI standard level. So today we're going to start with a question on finding the correlation coefficient. The Malvern Aquatic Center hosted a 3-meter springboard diving event. The judges, Stan and Minsoon, awarded 8 competitors a score out of 10. The raw data is collected in the following table. Write down the value of the Pearson's product moment correlation coefficient. So to do this, number one, you have to input your data in list form. It doesn't matter what graphing calculator you're using, you have to go to where it says lists, either on statistics or just say spreadsheets and lists. And then you input list 1 and list 2. Okay, so it goes 4.1, 3, 4.3, 6, 7.1, 6, 7.5, and 6. Then other list should go 4.7, 4.6, 4.8, 7.2, 7.8, 9, 9.5, 7.2. Then you go to calculations, stat calculations, and then you look for regression. And we're doing regression on the variable x. We're going to use the form ax plus b. Then you go, you have your r. So like I said, you follow this instruction on your calculator. You go to statistics, you go to the menu, you look for statistics, and you look for regression on the calculations. One variable, right? Doing one variable, no, two. Actually, we're not using any variables, just go to regression. We're doing the regression on x, and the form we're using is ax plus b. And the calculator says r is 0.9092. Then the next part says, using the value of R, interpret the relationship between Stan's score and Minsoon's score. When you're interpreting correlation, there are keywords that they want to hear. They want to hear, is it weak or is it strong? And any number that's close to, so this is like what the scale looks like. 1 is the extreme on this side, and -1 is the extreme on that side. And if they have no correlation, you get 0. So any number that's really close to -1 or really close to 1 would be strong correlation. Somewhere around 0.7, and that would be a strong correlation. And then if it's on the positive side, then it's obviously positive correlation. If it's on the negative side, it's negative correlation. So that's strong, keyword number 1. And then positive is keyword number 2. Yeah, that's how we can describe the correlation. Okay. Then it says, oh, still have some more key. Write down the equation of the regression line. We chose the form ax plus b. You can kind of see it on the calculator there. So what you need to get from your calculator is the value of a, and that's 1.14, and the value of b, and that's 0.578. That's the equation of the line. They said use your regression equation from part B to estimate Minsoon's score when Stan awards a perfect 10. If you go back to the table, you'll know that Stan's variable is x. So they're telling us Stan awarded a 10. That tells us x is 10. And then we're supposed to find y using the equation from the top question. So that's 1.14 times 10 plus 0.578. And when you put that on your calculator, you get 11.978. Say, state whether this estimate is reliable, justify your answer. It's not. You can't give a score above 10. So the score that they're estimating is out of the boundaries or out of the bounds of the question. So that can be a reason. Anything that just states the fact that you can't give a score out of above 10, right? The highest you can rate a person in this question is 10. Can't rate them 12 as it says here. Okay. 1F says the commissioner of the event would like to find the Spearman's rank correlation coefficient. So that's why I have this table here, the original table, just for the sake of finding out the ranks. So as you see, they ranked G as 1 here. That's the highest score for both Stan and Minsun. So that's kind of telling us that they're rating from highest to lowest. So let's do the same thing. So highest is 1. The next highest will be 2. 7.1 is the next highest. And then the next highest is these 3 that have the same score. So we would rank them normally. D would be 3 and F would be 4 and H would be 5. We would follow the rank that we've been using. So this was 1 and that was 2. And so what we would do, because they're the same, is we would find an average of those rankings. So we're going to do 3, add 4, add 5, and then divide it by 3, and that's going to be 4. So each one of those ones that had the same score is going to get a score of 4. Wow, I misplaced that too. So it's supposed to be where the 2 is, and that's a 4. This is also a 4. Okay, and then now we carry on with the ranking. We look for number 6, and that would be C. And we look for number 7, and that would be A. And then we're going to go and do the same thing on Minsun's rankings. We'll go, number 1 is G, number 2 would be F, and number 3 would be E. D and H have the same score. So again, we find the average of that ranking, and that's 4.5, which means both of them get a ranking of 4.5. You can see that they already had written 4.5 on H. And then now we look for number 6, and that would be C, and number 7 is A. Okay. And the next question says, find the Spearman's rank correlation coefficient. So that means we have to go back to the menu, go back to regression, and use the same list that, well, not the same list. We're going to change the numbers now, but use the same method that we just did to find the Pearson product moment correlation coefficients. Okay, so this time we're going to put the rankings on the list now. So that's going to be 7, 8, 6, 4, 2, 4, 1, 4. And then on the other side, we have 7, 8, 6, 4.5. I think I wrote 3 on E instead of I wrote E instead of 3, but yeah, that should be a 3, 2, 1. That should be a 3. Okay. Then where was I? 1, 4.5. And we go back to calc. Stat calculations, regression on X, X plus B. We're looking for R, the correlation coefficient, and that's going to be 0.933. And it says comment on the result obtained. So you put the input is the rankings, right? This time you input your rankings from question F onto list 1 and list 2. And then you put that onto statistics and you do the calculations just like we had done the product moment correlation coefficient. Yeah. So just gonna follow these steps here. These steps are the ones you follow again. Okay. Next question says comment on the result obtained for this Spearman's rank correlation coefficient. And what it just shows is that Sten and Minsoon agree on the rankings. Okay, next says the commissioner believes Minsoon's score for competitor G is too high, and so decreases the score from 9.5 to 9.1. Explain why the value of the Spearman's rank correlation coefficient does not change. It's because the number that came after 9.5 was 9. 9.1 is still greater than 9.1, so that means the ranking of that score remains the same, right? So that means the ranking of that score remains the same. The ranking of the score remains the same. Okay. Question 2. In a reforested area of pine trees, heights of trees planted in a specific year seem to follow a normal distribution. A sample of 100 such trees is selected to test the validity of this hypothesis. The results of measuring the tree heights to the nearest centimeter are recorded in the first 2 columns of the table below. Describe what is meant by a goodness of fit test. We normally use a goodness of fit test when we know that the data is supposed to follow a specific distribution. And so what we're trying to check is, does the observed frequencies actually match the expected frequency based on the distribution? Okay. So I will type this one for the sake of speed. It's a statistical test to check whether the observed values or data corresponds with the expected data from a given um, model. It's not always going to be binomial. I mean, a normal distribution, it could also be a binomial distribution. So it's just to check if your data corresponds to a specific given model. But yeah, that is why we do a goodness a fit test. Describe what is meant by the level of significance. It is the maximum probability that we can use to reject a hypothesis. If you get a probability or a p-value that is less than your significance level, you'd have to reject the null hypothesis. So that's how that works. Okay, 2C. It says, the heights of the trees seem to follow a normal distribution with mean 133.5 and standard deviation 56.345. Most of the expected frequencies have been circulated in the third column. Have been calculated in the third column. Frequencies have been rounded to the nearest integer. Find the values of A, B, and C to the nearest integer. You must show your working including the unrounded number that you got in your GDC. So let's go back to the table and look at some things. We're looking for A, and A is in this region. It's between 45 to 75 meters high, centimeters. So the nearest centimeters. Okay. And then B is between 135 to 165 centimeters high, and C is between 195 to 225 centimeters high. Those are the numbers that you need if you're going to use your calculator to find the expected frequency. So this is how we're going to work it out. For A, we're going to say that it's the expected frequency for A is going to be the probability that the height is between that was 35 to 75, I think. Let me just take that down. 45 to 75. 135 to 65, 165, 195 to 2. Okay, so that's 45 to 75. And we're going to multiply that by 100. That's how we get the expected frequency. And then B, we work out by doing the probability from 135 to 165. Also multiply that by 100 to get the expectancy. And then C, we'll find by multiplying 100 by the probability that the height is between 195 and 220. This is because they say that they measured 100 trees. That's why we keep multiplying it by 100. Okay. Let's go to statistics. This time around, we're looking for distribution. We're looking for the normal distribution. Every calculator is different. When you go to your statistics menu, yours might actually have a section called distributions, and then you just look for the normal distribution. We're looking for the normal CDF. And then here we can just put in the values as I've done already. Sure, I could erase them, but yeah, so we put 45 on the lower bound for the first one. And then we put 75 for this. And the standard deviation is 56.345. And the mean is 133.5. Then you get the probability 0.091449922. It says to write the unrounded number that you got on your GDC. So if I was to multiply that by 100, I would get 9.14492. Okay, let's do the next one. For the next one, we need to put the lower bound as 135, bound 165. The standard deviation and the mean remain the same. And the probability is 0.20131,891. When I multiply that by 20, it's 20 multiply it by 100 is 20.131891. Okay, let's go back. Again, we're going to do the lower bounds 195, the upper bounds 225, and the standard deviation is 56.345. The mean is 133.5. And then we do the execution. That's 8.533,267. Then they say to round them off to the nearest integer here. I almost say to the nearest teenager. That's funny. Round them off to the nearest integer. And that gives you 9 for A. And B would be 20. And C would be 9. Next is perform a chi-square test for the goodness of fit, find the p-value, and chi-square statistic. Okay, we need the table. This is why I'm going here. Now we know that this is 9, we know that's 20, and we know that this is also 9. Just gonna add those up to make sure that they really do add up to 100. Yep, that adds up to 100. Okay, so let's go to the menu. Then go to statistics. We need those lists again. So since we're already here, I can go to the list. Oh no. Great. I should exit this. Yeah, there. Okay. So the first list is going to be our observed frequencies, and that's 6, 11, 15, 20, 14, 10, and 6. And our second list is going to be the expected frequencies 6, 9, 16, 20, 20, 15, 9, 5. So then we go to the tests, the chi-square test. We're doing a goodness of fit test. You can see that it says observed is list 1, expected is list 2. And then for this one, we're going to need to actually work out the degrees of freedom. Unlike all the other tests, that wasn't really required. But let's write it down. So here we said that we input observed as list 1 and expected as list 2. That's list 1 and expected is list 2. Then the second thing we did was to go to statistics and go to the tests. And then there's a lag here. And go to the tests and look for chi-square, goodness of fit. Sometimes it's just written as GOF, and so that's also fine. Then What we're about to specify here is the V, the degrees of freedom, which most of your calculators write as df. And so that's just the number of observed, take away 1. So in this case, we have to do 100, take away 1. They observed 100 trees. So we have to make sure that that is 19. Okay, everything else is okay. And you get your answer. The chi-square statistic is 1.08, and the p-value is 1. And so we answer question E. It says, state the null hypothesis out. So our initial claim was that this data fits a normal distribution, right? So that is the null hypothesis, that the data fits a normal distribution. And then the distribution. And the alternative hypothesis is that it does not fit this. Doesn't fit the normal distribution. It's the opposite of what we just wrote down. And then our p-value was 1, and that is way greater. The highest we can get. P is P is 1, and that's greater than 0.05. As a result, we have to accept a null hypothesis. Then the data really does fit a normal distribution. Okay, that was the last question. Thank you so much for watching this video. I hope this helps you with your revision.